Welcome to WSHS Algebra 1 Virtual Tutor. Today we are going to be talking about solving literal equations. A literal equation is an equation that has several different variables. These usually take the form of a mathematical formula that requires you to solve for a different variable. Okay, so if you just think of some formulas that you maybe know that area equals length times width, or perimeter equals 2L plus 2W. So these are formulas that, you have multiple variables in it. So this is what we're going to be solving for today. So if you look at example 1, it says solve for the specific variable given. It gives you the equation AX plus BY equals C, and it wants you to solve for Y. So you take on the same steps like you would to solve a regular equation. The only difference here is you can't really simplify things because you have letters instead of numbers. So the first thing I would do is I like to box the variable you're solving for and draw a line down your equal sign. When you box it, this is you telling yourself you cannot move this variable. It's in like a concrete box, you can't move it. You can't pick it up, you can't move it to the other side. So what you have to do is you have to move everything else away from it. So what I like to do is I like to cover up the by and ask yourself, how do you move the ax to the other side? Well, it's positive ax, so to move it to the other side, we undo the positive with subtraction. So you're going to subtract ax to both sides. When we subtract ax and ax, they cancel, and we're left over with by, again putting a box around y, equals. I cannot combine a c with an ax. They just don't go together. So we just write it out, c minus ax. Next, now I ask myself what operation is happening between b and y. Multiplication. How do I undo multiplication? I divide. So you're going to divide both sides by what you don't want. I don't want the b, so I'm going to divide both sides by b. And when you divide the right side by b, because you have two terms, you want to divide both terms by that variable. Okay? So when we do that, we end up getting y equals c over b minus ax over b. Now, just be aware, you may see this same answer written as y equals c minus ax on your numerator, all divided by b. Both are correct. These are both representing the same thing. Example 2, again, says solve for the variable given. In letter A, we have A equals BH divided by 2, and it wants you to solve for B. So I'm going to put a box around B and draw a line. We have a fraction. We clear fractions by multiplying by the denominator. So you want to multiply both sides by 2. When we multiply both sides by 2, we end up getting 2A equals, our 2's cancel, BH. Again, I'm going to put a box around that B. Now, I ask myself the question, what operation is happening between B and H? Remember, when you don't see a sign, that's automatically multiplication. So B and H are being multiplied together. I don't want the H with the B anymore. So to undo it, I divide by H on both sides. When I divide by H, I end up getting 2A, all divided by H, equals B. And that's your formula solved for B. Letter B, it says A equals 1/2 H B1 plus B2. And it says solve for B2. So again, drawing my line down the equal sign. I have a fraction. My fraction is 1/2. To undo it, I multiply both sides by 2. Cancels my fraction, so you get 2a equals h times b1 plus b2. Now, this one's a little bit more complicated because you have the distributive property. In the distributive property, what are we really doing with h? You're multiplying. So to undo h, we would divide on both sides. So you can divide both sides by h, and now this eliminates your h on the right. So we end up getting 2a over h equals b1 plus b2. And I put a box around b2. I'm still drawing that line down my equal sign because I'm not done yet. And I have b2. b1 is being added to b2. Well, b1's positive, so how do I move b1 to the other side? You subtract b1. So minus b1 minus b1. So b2 equals, you have 2a over h minus b1. And that, ladies and gentlemen, is your final answer. 2a divided by h minus b1. Notice that the b1's off to the side. It's not on the numerator. It's not on the denominator. And that one's a challenging problem. Now on to the you try letter A. It says solve for x. So we have y equals 5x plus 7. So again, I'm going to put a box around x and draw a line down my equal sign. If I were to cover up my 5x, I have a plus 7 there. I need to subtract 7 to both sides. You're undoing the operation that's occurring. Y and 7 don't go together, so it's simply just y minus 7 equals 5 divided by x. Oh, sorry, 5 times x. Now, we're still putting that box around x. And what operation's happening between 5 and x? Multiplication. To undo it, we're going to divide by 5. And again, you're dividing each term on the left by 5. So we get y over 5 minus 7 over 5 equals x. Now, if you could reduce either of these fractions, you would. I cannot reduce y over 5, but I can't reduce 7 over 5 either. So this is my final answer. Or you could also have x equals y minus 7 all divided by 5. This is also a possible answer choice. Okay, so just be aware. It can all be divisible by 5 because this denominator is the same between each term. There are no additional notes. And let's just look at some of the practice problems. We have 15x plus 1 equals y, and it's asking you to solve for x. So again, I like to box the x, draw a line down my equal sign, and I'm going to cover up this 15x with my hand, and I'm going to ask myself, if I cover up 15x, I have this plus 1 left over. How do I move plus 1 to the other side? I subtract 1. 15x equals y minus 1 because they can't go together. Now 15 and x are being multiplied together, so to undo this, I divide each side by 15. And again, I'm dividing each term by 15. 15's cancel on the left. X equals y over 15 minus 1 over 15. And that works out perfectly. Number 2, it's asking you to solve for m. So we have y equals mx plus b. So we're going to put a box around m. It's very similar to the last problem we just did. We just don't have numbers. We have all letters instead. I'm first going to cover up that mx, and I'm going to say, oh, this plus b. How do I move plus b to the other side? I subtract b from both sides. So we get y minus b equals mx. Box up my m. What operations occurring between m and x? We have multiplication. To undo it, we divide each side by x and divide each term by x. So when we do this, we end up getting on the left y over x minus b over x equals m. And you're going to put a box around that. Again, you're just solving an equation. Main thing here is things can't simplify, okay, because you're using letters. For number 3, we have m equals y2 minus y1 over 2. Put a box around y2, draw a line down my equal sign. This time I have a fraction, so I'm going to multiply both sides by 2. And when I do that on the left, I get 2m equals y2 minus y1. The 2's on the right cancel. Putting a box around y2. How do I move negative y1 to the other side? Well, in order to undo negative y1, I add y1 to the other side. I cannot combine a 2m and a y1 together, so I just rewrite it 2m plus y1 equals y2. And that is your final answer. Number 4. Number 4 is x divided by g minus n equals p. Now, this one's a tad bit different than we're used to when we have fractions. So because our denominator is not under both my terms, I first have to undo the addition and subtraction. So if I'm solving for x, I need to move this negative n to the other side first. How do I move negative n to the other side? I add n to the other side. So I get x over g equals p plus n. Now, because the fraction is all by itself on the left, now you can multiply both sides by the denominator. So we would multiply both sides by g. Now, a little bit different. On our right side, we have 2 terms. So that means you need to put parentheses around it and multiply the whole right side by g. That means the p and the n get multiplied by g. On the left, our g's cancel, and our x ends up being all by itself. And you can distribute this through. So g becomes pg, and g times n becomes plus ng. And that is your final answer. Again, make sure you complete the practice assignment for literal equations. Thank you.